Hi, welcome to Introduction to Programming, and in this session we're looking at Unit 3 and our focus is on programming constructs. Now this will come in different parts, and this is the first part of this topic on programming constructs. Now what do we have? We intend to achieve the following in this lecture session. We want to understand what a programming construct is. Then we also need to know what a variable is and how different is it from a constant. And we shall move on to look at data types, and we shall give a little demo in the C language as well as the C++. Okay, so you know that C++ comes from C language, and I just want you to acquaint with the syntax of both languages. Okay, so let's get started. Now, what is a program construct? Now, construct comes from, or rather I can say the common word or term maybe we are usually acquainted with is construction, like the way people construct buildings. Okay, now one thing is whatever you're going to construct, you need building blocks. So if it is a house, we use blocks. We can use pan bricks, but well, there has to be material that you use to build something. And similarly, in programming, we also have the basic building blocks. Okay, we are talking about what makes up a program. So program construct refers to the way a program is constructed, and there are three basic building blocks. Okay, just like for you to build a house, you need bricks or blocks, and you're going to need cement. You're going to, and usually when you're building a building, it could be you are just going. There are certain things which are usually there. At a certain point, you'll be raising a wall. That could be one thing you encounter in construction. Another thing is making a corner. Another thing could be making the foundation. So there are these fundamental principles that govern building constructions. Now, likewise, when you're talking about programming is all about writing programs or developing software. And there are three things you always encounter when you are developing programs, and that is portions of a program will be written in a way that is sequential, and we call that a sequence construct. Another basic building block of a program is what is known as a selection construct, and thirdly, iteration construct, or what is commonly known as a looping construct. Now, in this first part, I won't go so much into these three constructs, but I want us to look at some fundamental concepts that we need to understand before we can go into that. And so important concepts to note are variables, constants, and data types. You need to know what these three things mean. Now, what do they mean? Let us start with variables. A variable, when you look at the word variable, it comes from the word vary, okay? Meaning something can change from time to time. Now, what it is when you write a computer program, a user is going to give this program some values. For example, if it's a calculator program, you may give it 100 plus 200, another person may give it 5 plus 2, or you, the individual, can give it different values at different times. Now, when you enter two numbers, for example, 10 plus 3, now when you are typing, you need to know that for a program to be able to receive those numbers don't just exist in thin air. There is a place where they need to sit, where they need to be located. And what that means is a computer has memory, okay? That memory holds information. So whenever you want to give a computer some numbers to add, what that means is there has to be some location in memory, and these locations, when you are writing code, you need to reserve them. You need to tell the computer, in this location, I'll be keeping such and such a value, okay? So a variable is actually a reserved memory location which is has been reserved in order to store values. So a variable is a reserved memory location to store values. And these values can be of different types. It could be integer type, in which case we usually abbreviate it as int. It could be a character like A, B, C. It could be a string, like a word. Okay, float. It could be float data type. Float means it has decimal points, like 23.56. So int is a whole number. Okay, it could be a 20, 100, but float means it has more precision. You are interested in values that follow after a decimal point. Now, a float has a precision up to a certain point. Maybe it can allow up to certain values. Double simply means it's a data type which has more precision, meaning it allows more values after the decimal point. Okay, so these are what you call data types. Now, let us look at the different categories of variables. Variables come in two categories. They are what you call global variables, and they are what you call local variables. And some of these things you understand them as we go on, but for now suffice to know that a global variable is one that is declared outside of the functions. So a program can have different functions, different blocks of code, each one doing a particular task. And a global variable is one you declare outside these functions so that it can be accessed by any of the functions in a program. So you don't want to localize it. Okay, so you make it global so that the different blocks of code or sections of a program can actually access those variables. Then there are also what are known as local variables, and a local variable is declared inside a specific function and can only be accessed by the function in which it is declared. Okay, now variable implementation. Let us see how a variable can be implemented in a program. So for example, if you are using the C language, you can indicate to a computer that in memory I want to reserve a location called quantity, and it should be receiving integer values. So let's say this is a program that we want to be calculating how much a customer has to pay on the till. So if a customer comes, let's say with packets of sugar, let's say there are 5 and one costs 10 kwacha. So if this person buys 5 of them, so you know that the unit price is 10 kwacha, the quantity is 5, and so we want the program to be able to calculate by multiplying quantity, meaning the number of items you've bought, times the unit price, and then it should be able to give the amount payable. So before the computer can actually calculate these values, we need to declare. Declare means we are giving an instruction that I want a memory location to be called quantity, another memory location, let it be called U price, that is unit price. And usually, if you notice, when you are giving names to variables, we want to abbreviate them so that as we are coding, you know, much of our time is not wasted in typing these long values. So, and we're going to declare another memory location, and we'll call it amount payable. And then now we can write an instruction to say unit price, in this variable called unit price, let us assign quantity, the multiplication of quantity and unit price. And then we may want to print the results of this function on the screen, in which case if you're using the C language, we'll say printf, and then we specify that well, this is integer, it will be storing decimal values, and we'll learn more about the syntax rules, but this just gives you an example of how variables are declared and used. So if there are certain things you're not understanding here, or just suffice to say this is how we can declare variables and how we can use them, but as we move on, you get to understand some of these things by and by. Okay, so but what is important is, at this point, I want you to know that there are acceptable ways of naming a variable, and there are certain ways which are not allowed. So if you want to reserve a memory space, there's a way you need to call it. There are ways which are acceptable and ways which are not acceptable, they're not allowed. So let's look at some of the rules for naming variables. A variable name can use alphabetical characters, a number, or even an underscore. And the other thing is, a variable name should not begin with a number and must have at least one alphabet. It should not be a reserved word. Now, when you are writing programs or code, source code, there are certain words you cannot use because they have a special meaning. So, for example, you can call a memory location quantity or unit price, but there are certain words you are not allowed to use them because they have a special meaning to the compiler. So examples of valid variable names or identifiers. Well, you can call a variable x. For example, if you want to write a program that calculates the area of a rectangle, you can call length L. You can call breadth B. Or if you want, you can call them xy, so that area is x times y or L times B. So you can call a variable by, well, a letter like x, L, B, whatever you want to call it. You can also name a variable using a combination of characters and numbers. In this case, num1. Let's say we want to write a program that adds two numbers. We can say num1 plus num2. So, but one thing is, don't leave a space, okay, between num and 1. You can quit num1. If you want to leave a space, you can use an underscore, the way we've shown it here. First underscore, then num. Or first or num, then underscore, then 1. Yeah, that is acceptable. But we can also give examples of wrong identifiers like print main. Well, what is wrong with this? Well, main is a reserved word. It has a special meaning to a programming language. Now you may wonder, you say, well, Andy, how do I know now this is a reserved word and this is not? Well, as you go on doing programming, there are certain things you just learn them as we move on, as we do some practice, as we do some exercises, okay? Now, when you look at the second one here, it says one num. This is not allowed. You can't name a variable starting with a number, okay? Then what is wrong with the third one? There's a space here between num and 1, okay? If you want to make this into a valid identifier, then don't leave a space here. Now, I need to mention that there's also what is known as a constant, and it's an opposite of a variable. A variable can accept different values which a user enters, but a constant, well, is a constant. A constant is a value that never changes, okay? And because of their inflexibility, constants are used less often, okay, than variables in programming. Now, a constant can be a number, okay, which you declare in a program. A number, any number, okay? And it can also be a character like a dollar symbol. Okay, you want it to be just like that, and it has a meaning. It's a currency symbol. Or it could be a mathematical constant like pi. Okay, so if you want to write a program, for example, that calculates the area of a circle, at one point you use pi. Is it pi r squared or something like that? So pi has a special value. It never changes. It's usually represented by 22 divided by 7, 3.142. Usually that's the estimate which is usually given for that kind of a constant. So that's what a constant is. Okay. Now let us look at the third item we said we want to mention, and that is data type. Now when you declare a variable, the other thing you need to state is what type of data values will it be receiving. Will it be integers? Will it be string values? Will it be a character? Now, a data type in programming is a classification that specifies which type of value a variable has or what it can hold. Okay, and so all in all, we can say a data type in programming is a classification that specifies which type of value a variable has and what type of mathematical, relational, or logical operations can be applied to it without causing an error. Okay, I'm getting this definition from TechTarget, and well, they put up a good explanation of this. So that's what a data type is. So if, for example, you want to add, you may want to use int. You want a variable to be holding integer values or float values. But if a variable has been declared to only accept string, well, you know, those are alphabetical, those are words, okay, and you can't perform arithmetical operations on them. So that's what data type is, and there are different types of data. Okay, there's string. Okay, so in this table there's data type, and here we're explaining what they're used for, and here we're giving an example. Now please, as you are listening to these lessons, have a notebook. If you want to make notes, if you want, you can pause and you know, you just make out some notes. And string, like I just earlier explained, these are alphanumeric characters. Okay, these could be words, phrases, name of a person, and all that. It could even be numbers, but which are not used for calculation. They're just maybe used for identification purposes, like a number plate of a vehicle. It can be BLA 1, 2, 3, 4. It's a combination of characters and numbers. And numbers, they are acceptable because we're not using them for calculations, but for identification purposes. Just like a student ID, you may want to declare it as a string. Now, integer, these are whole numbers. Okay, 7, 12, 999, 1000, and all that. Then there's float, or what you call floating point. So these are numbers with a decimal point. Okay, numbers with a decimal point, like shown in the example there, 3.159, 0.06, and so on and so forth. Then there's also a character. Okay, a character is a character like A, B, C. Okay, just a single character. Then there's Boolean. Boolean represents logical values. Okay, this speaks of whether a given expression results to true or false. So we call those Boolean values, and you will appreciate them as we get into programming exercises, coding exercises rather. Okay, so for now that's it.